Hey guys, this is Emily, and I'm going to be talking about forensic evidence. I've actually created a brochure on common forensic evidence. This video is just going to highlight some of the information from my brochure. You might not even have an interest in forensics, so you might be wondering, why is this information going to be useful to me? No one wants to think about being part of a crime scene, though we all know crime is a continuing problem. Wouldn't it be nice to be prepared? You could even accidentally contaminate evidence. But in this video and in my brochure, you'll learn how to preserve evidence and collect it. You could even start your own investigation if no one else will. I've broken down forensic evidence into 4 categories: biological evidence, fiber analysis, print examination, and weapons forensics. Even though we can't get a 100% match on DNA, we can get pretty close using short tandem repeat. This method evaluates specific regions that are found on nuclear DNA. The chances of someone else having the same DNA profile as you can be as high as 1 in 1 billion. Considering there is about 7.5 billion people on Earth, this is as close as you can get to a definite match. Unfortunately, not all DNA evidence can be tested using short tandem repeat. Things like hair shafts, which is just the hair without the root, bones and teeth have to be tested using mitochondrial DNA analysis. All maternal relatives have identical mitochondrial DNA. That means you share this with your mother and your grandmother, and it's helpful in identifying missing persons and unidentified remains. Another useful method is the Y chromosome analysis. It targets the male fraction of a biological sample. It's helpful when there's multiple male contributors to a sample, and it also helps trace family relations among males. When looking at blood spatter, there are 3 levels of impact: low, medium, and high. Low impact is due to the normal force of gravity, and they're going to be large and circular. Medium impact is usually from some type of blunt force object, and it's going to be large drops broken into smaller splatters. High impact is going to be high force from shootings or explosions, and it's going to take on a mist-like appearance. Next, I'm going to be talking about fiber analysis, and the most common way to analyze a fiber is with microspectrometry. It's most widely used because it does not destroy the fiber sample. It uses light to determine the color of a fiber and then match to a known sample. Another good method is thin layer chromatography, but this actually destroys the fiber sample, but it uses a solvent to determine the exact dyes of a fiber. There are so many fibers everywhere, you need to know where to look in order to create a good sample. Below are places to look depending on the crime. You can pause this video and look at more in depth if you like. This image shows exactly how fingerprints are matched. Someone manually compares the similarities. A computer is not used to do this, though the print can be put into a computer database to find the top 50 potential matches. Criminals normally wear shoes, so we don't think a lot about collecting footprints. But the cool thing is, as footprints are just as unique as fingerprints. Lastly, I'm going to be talking about ballistics. Most guns have their own unique identifying features. The barrel contains small ligatures and grooves. When a bullet's fired, it creates unique markings on the shell casing that can be linked back to that exact gun. Also, shell casings can identify the make and model of a gun. The shooter will also have residue on his or her fingers and can leave burn marks on the victim if the gun was too close. Check out my brochure to learn more about forensic evidence. Be informed, be prepared. You never know what situation you're going to end up in.